I'm a PhD student in apprenticeship of the University of Turin. I work in the Department of Mathematics. And today, some previous presentation already told about the importance of problem solving and the use of an advanced computing environment. I would like to deepen this topic. Most of us, maybe all, agree that problem-solving competencies are important to develop for the students, first of all. Problem-solving competencies are so important that they are chosen as one of the measures for evaluating instructional systems. And also, national education systems has issued new indication and action for teacher training based on problem-solving and advanced computing environment. They use new technology. Europe asks schools and institutions to prepare the students for a world that is constantly changing, a world of work which the problem-solving attitude is needed. With our working group, we make some assumption of problem solving. Problem solving can be described in many different ways. What do we assume? That problem solving is composed mainly by two processes, which are the modeling of the situation and the expression of the reasoning. These two processes that can be found inside the problem solving are deeply intertwined. They cannot be separated. Moreover, the modelization of the situation when facing a problem cannot be entirely made through the mind of a student. He needs words, numbers, symbols, graphic and simulation tools. Lastly, mathematics. Mathematics is not only needed for fulfill the problem-posing and problem-solving process, but it's also strengthened after the implementation of the problem-solving process. And now I'll repeat some of the features of an advanced computing environment, such as Maple. It's a tool that let the students and users do geometric visualization, symbolic calculus, procedures, interactive components. The main importance about an advanced computing environment is that they all can be integrated in a single environment, in a single worksheet. So what are the effects of the use of an advanced computing environment for the problem-solving process? Well, students, first of all, can focus on solving rather than calculating, which is very important. And a wider range of problems can be proposed by the teachers. The integration, the possibility of integrate different modalities led to a diversity of solving strategies found by the students, by each student. Each student, during the solving process, is free to choose which modality he can use, but it has to justify and validate his reasoning. High level of clearness by using an advanced computing environment can be achieved. I will show you an example of problem posed and solved within an advanced computing environment. But firstly, I'd like to show you some features of the problems that we pose to students. They are real-life challenging situations. They must be connected to different disciplines and open to non-standard solutions and customized situations so that each student may apply the problematic situation to his own particular case. And math is needed, it's fundamental, but practical applications are proposed. Optionally, and we do that for example, it's more easy for the assessment, but also for the student not to be how can I say, be more facilitated to solve the problem, to divide the the text of the problem in distinct questions, increasing in difficulties. At the end, very important, there is the request of the resolution of a general situation based on the same posed problem. Before going to the example, I show you that we, as a working group, work in many different projects, many different actions. As a university, for example, we propose problem solving in summer schools, as core projects, theses for teaching, and also propose this methodology to the teachers for collaborative work among a group of students, for school remedial, for example, Scuola dei Compiti, School of Homework, the presentation that Alice Barana made previously. But today, I will tell you about digital math training, which is a project that proposes mathematical training and competition for solving problems. This project is held mostly in one academic year. It's held by tutors. And tutors, first of all, most of the tutors are here in this room now. Maybe you met them before. We start the project by a classroom training, so the whole classroom received training in the school labs. Then it starts from selected students training online in a virtual learning environment where many activities, for example, how to use an advanced computing environment with web seminar or forums and self-peer evaluation and many others. They learn the collaborative work and how to solve a problem. After 10, 12 problems, we select the best ones and they will arrive to the final competition in a lab of the Department of Mathematics. This is one of the problems that we posed to the students at the final competition last year. It was assigned to grade 12 students, as the segment. It talks about a mechanical toy with a mechanism that makes a siren sound when it turns on. It consists of two gears rotating one against the other, as you see in the picture. And on each gear, in a point of the external cogwheel, there is an electrode. So at the beginning, the two electrodes are connected. The wheels start running. And since they have the same radius, the toys work. Which is the first question that we pose to the students. Provide a graphical representation of the situation in this case. You see two examples of solution to this question the students made. They are different in the formula used. But in each of those, objects must be declared through their mathematical properties, which is mandatory when you use an advanced computing environment. So different solutions are the expression of different reasoning, and modeling and representation, as I told you before, cannot be separated. This is a first example of this. Now I'm going to a second question that we posed, the question about the generalization of the situation. So this was the simple one. Now a more difficult question. If the two gears have different radius, so that you cannot express them as to the same radius circumferences, how must the radius ratio be in order for the toy to work? Will it work? Explore this situation through interactive components. Then find a relation that the radius ratio must satisfy in order for the mechanism to work. This one was one of the solutions they gave, made by interactive components. And students at the beginning of this project were not able to use Maple, maybe. Maybe it was the first time. They, in few months, learned how to solve a problem within Maple and reached this kind of complexity. they were able to explorate the situation. And this exploration addresses them towards the solution. However, this was only an exploration. Mathematics, algebra, algorithm are needed in order to generalize and find the correct solution. After this example, how do we assess the problems, their solution to the problems? We have and developed a rubric with 5 indicators, and each indicator is divided in 4 levels with points. The maximum point was 100. And you see at the end, one of the indicators is the appropriate use of the advanced computing environment. They have to use it properly to solve the problem, not only to add some features, but useless. In general, about the assessment, the advanced computing environment can give many aspects. For example, during the solving process, so while the student is solving the problem, he can immediately and constantly validate the reasoning. After that, instructor, when they keep the solution from the student, can identify the student reasoning, as I showed you before, and find unexpected solving strategies. Lastly, maybe the teacher wants to propose a solution, a synthetic solution, and inside this synthetic solution can embed questions for self-assessment, so that also who didn't answer correctly can assess and continuously learn. To finish, we measure the appreciation of the project, for example, appreciation of the use of the advanced computing environment. From 1 to 5, the points were given both from students and teacher, 0.4 on average. This is from 1 year of the project, in which they were involved 4,000 students and approximately 100 teachers, if I'm right. And each year, the numbers are the same. We asked also about the usefulness of the use of an advanced computing environment for the problem solving, and the results are quite positive. It's very good that they think that they acquired skills spendable in the working world, which was one of our aims. I want to finish this presentation with a look towards the future. So right now we are using the advanced computing environment in desktop, in the labs. But what about, will it be possible to have a mobile advanced computing environment? Thank you for the attention.